Hello guys, what's up? Am I live? Yes? Please tell me in the comment section whether I'm live or not. Give me a second. Let me check whether I'm live or not. Okay. So childrens, give me a second. Let me check whether I'm live or not. Okay guys, it seems I must be live. Can you able to see my screen? Okay guys, it seems I must be live. Okay. So guys, welcome to my video tutorial. It's me Arun Thakur, and today I will be beginning with, or tomorrow I already have begin the chapter that is atomic structure, and we have discussed a lot of things regarding this chapter. And so today this is the part 2. Which part is this? This is your part 2. Fine. Let me just minimize the video. Okay. Okay. So today childrens, this is the part 2 of the atomic structure. Again, this is being presented by me, that's Arun Thakur. So without any delay, let's begin with the chapter. So you remember, give me a second. So today children, this is the part 2 of the atomic structure. Again, this is being presented. Okay, perfect. I'm clearly audible and visible to you. So tomorrow I had told you regarding the timeline of this atomic theory. In this timeline, what I have discussed with you regarding the Greek models. Means I had just tell you that firstly the initiative was taken up by the uh, Greek scientists. After that, Dalton's model come up, then Thomson's model, Rutherford. I think I have told you the Dalton's atomic theory. Then I have explained you the discovery of electrons, protons, and neutrons. Protons, and neutrons. I have discussed the discovery of these three things, and further we have discussed the Rutherford's model, then Bohr's model. So Bohr's model, I had just told you that he called the different shells just the names. Means he said that um, the electrons revolves around the nucleus in a fixed path that is known as orbit. Just this thing I have told you, but I haven't explained you his model thoroughly, properly. So first of all, let's understand this thing, and then we will again come to the Bohr's model. Clear? So let me quickly recapitulate what we have done. We had done the Dalton's atomic theory, then the subatomic discovery of subatomic particles, that is the discovery of electrons, then its discovery properly. This experiment I have taken up. Then we have also taken up the discovery of protons and neutrons. Protons discovery was done by E. Goldstein, whereas the neutrons discovery is done by James Chadwick, right? Okay, so atomic models we have done, the Thomson's model we have done, then Rutherford's model, nuclear model we have done, and its limitation I already had explained you tomorrow. Then okay, I have explained you the different concepts of isobars, isotopes, as well as one more thing. What was this? That was isotones. I have also explained you this thing, right? I had explained you now. Okay, then isobars, isotopes, further the drawbacks of Rutherford's model. I have discussed with you this thing. Then the electromagnetic theory. So today our concept is that we will be beginning with the electromagnetic theory. So let's begin with this thing. You know, according to the electromagnetic theory, when the charged particles are accelerated, they emit some electromagnetic radiations and will ultimately falls into the nucleus in a spherical path. Thus, he could not be able to explain the stability of the atom. Tomorrow, I haven't taken this name. I had just told you that according to the classical physics, these electrons would must fall like this diagram I have shown you. If you haven't watched that video, go and watch it that time, right? So again, I also had opened the book so that I can tell you that what type of thing this Dalton theory we have done, its postulates, then subatomic particles we have done, discovery of electrons we have done. It's, I think it's the third time I'm explaining you this. So I these relative charges and absolute charges. So what happens if you find the charge, you know, symbol of an electron is like represented by E. Its absolute charge is 1.6022 into 10 raised to power minus 19. And if I'm talking about the relative charge, its relative charge is minus 1. If its mass is 9.10939 into 10 raised to power minus 31. And it's, if I'm talking about mass is 0.0054, means approximately it equals to 0. If I'm talking about protons detail is in the front of you, that this is represented by the symbol P like this, and its absolute charge is just the thing is that this is positive charge. It's same that of electron. Relative charge is plus, then mass is 1.67262 into 10 raised to power minus 27. Then its mass is just relative mass, remember it's 1. Neutrons, its absolute charge is 0, relative charge is 0, mass is 1.67493 into 10 raised to power minus 27, and its mass is 1.00867, and its approximately mass is equal to 1. Okay, we have done this pump winding model of Thomson. Then I had discussed with you the Rutherford's model. Okay, then isotopes, isobar we have discussed, atomic number, mass number we have discussed. Then we have what drawbacks, I think we have discussed. Yes, so now the development leading to the Bohr's model. So I told you now that first we need to understand the development. We have to create some base, that how that Bohr's model is being, so means how the Bohr uses his brain in order to get this model, his model. Hope that everything is okay. I'm quite visible to you. I think there is net error, but it will be soon recovered. Just a second. I think net is fluctuating.